So in this video, we are going to discuss about dynamic latches and registers. So if you see the static latches, that is static sequential circuit. So in static sequential circuits, the storage is depends on the cross coupled inverted pair, which produces a bistable element, right? Which is used to memorize binary values, right? Example, zeros and one. So this storage remains valid as long as the supply voltage, the supply voltage is applied. So that is why it is called a static. So what is the disadvantage of this static logic is complexity. Because we have to employ the pipeline data path, so it requires a memory, right, to hold the state for the extended period of time. So this will result in the class of circuit which is based on the temporary storage of this charge on the parasitic capacitance. So this principle is exactly used in the dynamic logic. So here we are going to use a capacitor. In dynamic CMOS logic, we are going to use capacitor. So if it is charged, if it is fully charged, means we can term it as 1. So if it is discharged, otherwise absence of charge, we can term it as 0. So what is the disadvantage is there is always some leakages present. Charge leakage. So therefore we require some periodic refresh of its value is necessary. So that is why it is called as dynamic storage. That is why it is called as dynamic storage. So in order to read the data present in the capacitance, so to read the value of the signal, from the capacitor, so it requires the availability of the circuit with a high impedance, with high input impedance. So first let us discuss dynamic. Transmission gate, age trigger resistor. So it is based on the concept called master and slave.
Yeah.
So you can see this is my circuit. Okay.
Done. And ready.
So D
Clock. The clock what?
So you have a capacitor. Okay. So C1, 1. Then you have an inverter. Then again you have a transmission gate, clock bar. So this second term it is T2 and this is T1. Okay. So the C2, 2 and inverter.
So
whenever the clock is 1. Okay. Another clock is 0. This input data, the D get this will turn on. Okay. The T1 is on. Okay. So therefore the data gets sampled on the storage node. Okay. So the D will reach this capacitors. Okay. So this C1 is nothing but the equivalent capacitance, which consists of the gate capacitance of I1, then junction capacitance of T1 and overlap gate capacitance of T1. So whenever this is conducting, okay, when clock is 0, this is this part. Okay, this is nothing but transparent. Okay, and this part. Okay, this part is opaque, right? This is transparent and this part is opaque. So the whatever the value will not reach the output. Okay, during this period. Okay, so I can term this one as master and this one as slave. Okay. So what is the value that is in the node 1 is D. Okay. So this is the slave mode is in the hold state. Okay, hold mode. And the node 2. Okay, and node 2 is in a high impedance state. High impedance, it is also called as floating state. Okay. So next condition, whenever the second condition, so during the rising edge of the clock. Okay, during the rising edge of the clock, what will happen? T2 is on. T2 is on and T1 is off. Okay, so this becomes a master. Okay, this becomes master and this becomes slave. Okay, so my T1 is off state. Okay, so the node 2, okay, the node 2, this value, okay, it stores a so D initially the node 1 it will store the value of D, so it get inverted and it is stored in the value of in the node 2. Okay, it stores the inverted value of D. Okay. So it is so since it uses only 8 transistor. Okay. So how come it uses 8 transistor? You can see I have 1 PMOS and 1 NMOS, and here also I have so totally 4 transistors I use for implementing this inverter. I have to use 2 transistors. So 2 plus 2 4, and this one is 4. So totally I'm using 8 transistor. Okay, in order to implement this, so it becomes efficient technique. To implement. So this is nothing but a positive edge trigger. Okay, this is a positive edge trigger register. So why I'm telling this one is whenever this clock is 0, so whenever the clock is 0, the D value was stored in the node 1. Okay, so whenever the clock is 1, whenever the clock is 1, so the D value, okay, the D value will reach the Q. Okay, so it is working as a positive edge trigger register. Here. So if I change this clock bar to clock and clock to clock bar, it will work as a negative edge trigger flip-flop, edge trigger register. Okay. So this instead of transmission gate, I can also use the NMOS pass transistor logic. So if I use NMOS transistor logic means so instead of the transmission gate, I can use NMOS past transistor logic. So thereby I can reduce the number of transistors to 6. Okay. So which will result in a high performance and low power systems. So here if you see what is that setup time, okay, so this is my circuit. I can for setup time of the circuit, this setup time is nothing but the D has to reach the node 1. Okay, so let me assume this one. So in order to reach this node 1, it has to take the setup time of the circuit. Okay, setup time of the circuit, okay, simply that is TSU is equal to the setup time of this transmission gate, delay of the transmission gate. Okay. Next, hold time. Okay. The hold time of the circuit is 0. Okay. So why the hold time of the circuit is 0 means this D will not reach here. Okay. Since whenever this transmission gate is on, this gate is off. So therefore, this D value will not reach the node 1. Okay, whenever this transmission gate is on. Okay, so therefore the hold time of this circuit is approximately 0.
What?
Next, TCQ. Okay, it is nothing but a, so this is a hold time, and this is nothing but a propagation delay. So the propagation delay of this, the propagation delay is nothing but when the value at the 1 will reach the Q. Okay, so in order to reach from 1 to 2, it has to cross this 2 inverter and 1 delay of the transmission gate. Okay, so this TCQ is nothing is equal to delay of 2 inverter and transmission gate. T2, this is I1 and I3. Okay.
And it did it had it in it.
So there is a problem on this positive edge trigger flip flop. Okay, so consider
You are for the audio.
these are my this is my clock period. Okay, this is clock, and this is nothing but clock bar. Okay, so if it is clock bar means it is the inverted value, right? but due to some environment condition, consider that it get delayed. Okay.
Yeah, going the players.
Okay. I considered this is my clock and this is clock bar. So due to some environment condition, consider it get delayed. Okay. So you can see here during this period, both the clock are 0. Okay. During this period, you can see. So this is called as T00 overlap. And this period, okay. So this period is called as T11 overlap. So what happens when T11 overlap? You can see this clock is 1 and clock bar is 0. So therefore, after the 1-1 overlap, clock is 1 and clock bar is 0. So clock bar is 0 means what will happen? Whatever the input at the node 1 will reach the output, right? So let me turn. So after this T11 overlap, okay, this T2 transmission gate is on and T1 is off. All right. So definitely my input will reach the output, right? So D will reach the Q. Okay. So therefore, in order to avoid this one, the constraint for the T11 overlap is T hold time must be greater than T11 overlap. Okay. So we can see for the T00 overlap. So during after T00 overlap, clock is 0 and clock bar is 1. Okay. So clock is 0 means this T1 is on and T2 is off. Okay. So after the so during this time, T1 is on, right, and T2 is off. Okay. So therefore, the D will not reach the. So during T00 overlap, T1 and T2 is on. So after T00 overlap, T1 is on and T2 is off. Therefore, D will not reach Q all the time. Okay, only for T00 overlap, T will reach the Q. So after that, D will not reach the Q. Okay, so therefore I can impose the constraint as T00 overlap is less than T1, T1, Ti1 and Ti2, because I'm going to consider the D has to reach the 2. Okay, that is why I haven't included the I3. Okay. So if this condition is not met, the D will reach the Q, so it will cause us the race condition.